Welcome everyone. In this video we will prove that the circumference of a circle is given by the formula 2 pi r. I know that probably all of us watching this video have heard of this formula and used it countless times perhaps. But where does it actually come from? Well, in this video we will prove that this is correct using calculus. So to start off, let's draw a circle on a coordinate plane. And of course, I will choose a XY coordinate plane because it is the most used one, most convenient one. And let's draw a circle with radius r. And notice that it is centered at the origin. And the more general case would be a circle anywhere on the plane. But I guess that I can convince you by simply saying when you move the circle around, the circumference doesn't change. So we can basically consider the easiest case where it is centered at the origin, and you can just shift that circle anywhere you want and you will have any circle possible basically on the XY plane. So the proof that we're about to make works for any circle. And of course, enough with that side note. Now, what is the formula for the circle? The formula is x squared plus y squared is equal to r squared. Cool. And any shift would be written like x minus a squared, y minus b squared equaling r squared, okay? That's the shift business, but we don't need to account for it because, as I said, you can always shift the circle and the circumference won't change, and or even better, you can always choose a coordinate system such that the circle sits at the origin. How about that? Okay. So for now, I want to solve for y. Y will be r squared minus x squared under the square root plus or minus. Now I can see that this shape is symmetrical. So what I can do is I can work with one part of it and then I can multiply the result by 2 to get the whole circumference. And I choose to work with the positive part. So it is, I don't need the plus here. This is the y. So for the circumference then, let's say the C, the circumference, I will have 2 times the length of this upper section. So all of the question boils down to calculating the upper section's length. And how do we do that? Well, there is a way of calculating the length of any curve, and that is using the arc length formula. Now let me write it. So for that we will have an integral, and the integral will be going from, just like close the lower part for now, we're only interested in this orange part, and you can see that the x values, they start from negative r and end at r. So that's the boundaries of our integral. And in the inside, the integrand is the square root of 1 plus dy dx squared. So the derivative squared for the function that we are interested in. And then you have dx. And you might be saying, where does this come from? Well, it is very simple. We could discuss this in more detail, but where it comes from is basically this. You have any curve and you want to find its integral, its length, arc length. What you do is you choose dx and dy along it. How do we find this dl? So you say, I will add all the dl's. How do you find the dl? It is the square root of dy squared plus dx squared, right? But just by using the Pythagorean theorem. So that's right. And if I just, let me do this. If I factor out, we have the integral. If I factor out dx squared, we will have 1 plus dy over dx squared. And I just take the dx squared out to leave us with this familiar looking equation. Okay? Dx didn't fit there. We have the dx outside of the square root. So that's where the arc length formula comes from. There is nothing miracle here, okay? There is nothing magical here. It's just basic manipulation of the Pythagorean theorem for integration. So I guess that we are on the same page for this one. Now comes the part where we take the integral. I keep messing the words, guys. Anyways, this is the part where we take the derivative, because we have it here and we need to substitute for it. So dy over dx, what is the derivative of this? Well, let's integrate the inside with respect to x. R is a constant. The derivative of negative x squared is negative 2x times. So it is to the power of 1 over 2. We have 1 over 2 and then r squared minus x squared under the square root. So it is basically minus x, r squared minus x squared under the square root. That's the derivative. And we're just going to substitute that. We're just going to substitute it. Negative r. We have the square root, 1 plus. For the dy over dx, we will just square it and substitute. So x squared over r squared minus x squared and then dx. And I think you can see that if we were to combine this part under one numerator, one denominator, we would have, let me write it step by step. So 1 plus would be under the same numerator, under the same denominator. That's what we have. Negative x plus x, they simplify. So we basically have r squared over r squared minus x. Okay? And of course, I can take the r squared out of the integral now. Well, first out of the square root and then out of the integral because it is a constant. So we have 2r, negative r, and then r squared minus x squared to the power of negative 1 over 2, right? dxn. And if you look at this integral, you will realize that you can't solve it right away. You will need to do a substitution. And that substitution is a trig substitution. For that, I will say that if we were at this point, this would be x. And I can define this angle to be theta. Now, what is cosine of theta? Cosine of theta, that is x over r. So x is just r cosine of theta. And if I take the differential on both sides, it says that dx is equal to negative r sine of theta d theta, right? Because the derivative of cosine is negative sine. Which means that we're just going to substitute this now to the x part. Because otherwise, you can see that we can't take this integral. If you can take it from top of your head, then go ahead. But I cannot. I need to make this substitution. We have 2r. And the boundaries, now, they won't be r and negative r. Because we just transitioned from x to theta. These two boundaries can't be in terms of x. They need to be in terms of an angle. And we will determine those angles in a couple of minutes, hopefully. Okay? Let's first write the integrand though. We will have r squared minus, instead of x, I'm substituting this business, which is r squared cosine squared theta. And it is to the power of negative 1 over 2. Then for dx, we're going to have this business, which is negative r sine of theta d theta. And let me put the parentheses so that you understand it's not a subtraction, it's a multiplication. Now, on the business of the boundaries, just imagine when x is at negative r, all the way at negative r, we're there. What is the value of theta? Well, we just transverse through a half circle, which corresponds to a pi. That's pi radians. And what is the corresponding angle when when x is at r? It means that theta just goes to 0. It's 0, okay? So that's how we determine the boundaries. And here, let me do it step by step. So we can just get rid of this negative by switching the boundaries. And I will take the r out, so r out. So it will be 2r squared. I switch the boundaries to get rid of the negative sign. We will have then sine of theta, d theta, and this part, if I factor out the r squared like this, it's going to be this, right? I hope this isn't fast for you. I think that you can follow this. And if you can't, just stop the video, get a piece of paper and a pencil, and work it out on your own. So, this part, that's just sine squared theta. And we raise it to the power of negative 1 over 2. That would give you sine to the power of negative 1, which is 1 over sine. So, this and this, they simplify. And also, look at this part. That part is r squared to the power of negative 1 over 2. That gives you r to the power of negative 1, which is 1 over r. So this part and one of the r's here, they simplify. Leaving us with 2r. Be ready for this, because this is about to be one of the easiest integrals that you can take. The integral from 0 to pi, you have d theta. That's it. And what is the integral of d theta? It is just theta. You have 2r theta from pi to 0. And just the finishing touches here 2r, you substitute pi. You substitute 0, there is a minus of course. You get 2r pi. Well, we won't leave it like that, will we? We will, of course, write it in the very familiar form, 2 pi r. And just like that, with a little bit of calculus, you can see that the circumference of a circle is 2 pi r. Anyways, I hope this video was helpful. If you want to see more content like this, please be sure to subscribe, and I hope to see you in another video. Until then, take care.